Hello बच्चों. So in this session we'll learn how to write the nomenclature of alicyclic compounds. So already you know what is alicyclic compounds. Let us see the nomenclature. So in this case we use the term cyclo as a prefix for writing the nomenclature for cyclic hydrocarbon. So rule number 1, for normal cyclic hydrocarbon, how do you write? So this is the simple hydrocarbons, propane, but you have to use the prefix cyclopropane for 4 carbon. So it is butane, so cyclobutane, 4 carbon, cyclobutane. Similarly, this will be 5 carbon, cyclopentane, 6 carbon, cyclohexane, 7 carbon, cycloheptane. Here we have how many carbons we counted? So there will be 10 carbons, so it is cyclodecane. And there is again one double bond is present, so it is your alicyclic unsaturated compound. So we use the term cyclohexene. Here we have one double bond, so alicyclic cyclopentene. Okay, so we if you start name also one from here, start name is cyclopentene. Now here we have two double bond in cyclic compounds. We use to them cyclohex. It is your 1,3-diene. So hexane. It is cyclohexane 1,3-diene. So it's one carbon double bond. This is hexane. So 1,3-diene. Similarly, in this case, if you see the carefully, so here we have so 5 carbons are there, 6 carbons are there, and double bonds are there. So we can write cyclohexa 1,4-diene. Here this is cyclobuta, so 1 carbon, 3 carbon, cyclobuta 1,3-diene. Here we have 5 carbons we use here, 1,3, cyclopenta 1,3-diene. I hope you have understood this rule number 1. So if there is no substituents, we can directly write the nomenclature. Now if the ring have, now we have second rules is that if the ring contains more or equal number of carbons, so if a ring contains more or equal number of carbon atoms, then the alkyl groups attached to it. So now we are attaching the ring with the alkyl groups. Now if the alkyl groups carbons and ring have both are same or more, if ring number of carbons the ring is more, then alkyl group is treated as a substituent. So remember, number of carbons in the alkyl group is same or less than the rings, then alkyl group is always treated as a substituent. Let us see some examples. Here is example. So this is your 6 carbon is a ring and 1 carbon is methyl. So we write here methyl cyclohexane. So 6 carbon is more than 1 carbon, 1 carbon is alkyl. So this is difference. Now the ring contains 5 carbon and the such alkyl consists of 2 carbons. So therefore it is small. So we use ethyl cyclopentane. This will be your substituent. Here again we have 4 carbon and 4 carbons in this. So this will be again treated as the your prefix. Which one? This alkyl group. So it will be butyl cyclobutane, because rule says that the ring and the number of carbon in the rings and this must be same or the alkyl group must be less. Then alkyl group is in the alkyl group is treated as your substituents. So both are equal, so it is substituent. Now here is also there are 2 alkyl groups, one is there, so we can write 1,2-dimethyl cyclopentane. There are 2 substituents are there. In this case, you can see methyl and ethyl is there. So ethyl is given more priority, alphabetically order. So it is 1 methyl, 3 methyl cyclohexane, 6 members are there. And here also this is a complex substituent. So we can write 1 methyl, whole compound is propyl, 1 methyl propyl complex substituent, and this is normally cyclohexane. So now we'll see if the ring contains less number of carbons than alkyl groups. Now ring contains less number of carbons than alkyl groups attached to the rings, then the ring is treated as a substituent. How? So here we have examples. So this is 4 members are there and the number of carbons in alkyl group is more than that of the ring. The ring is 3 carbon. So the ring is treated as a substituent. So we can write here 2-cyclopropyl. This is 2-cyclopropyl. And this longest carbon is butane, right? And here we have 1, 2 and 3, 4, 5, 6. So 6 is definitely hexane. So this will be hexane, the longest carbon chain, and the third carbon is cyclobutyl. So we can say 3-cyclobutyl. So I hope you have understood this one. Now here we have 5 carbon, but the longest chain 1, 2, 3, 4, 5 and 6. 6 carbons are just there, so it is called as hexane. And this carbon will be 1, 2 and 3. 3 is your cyclopentane. We can 3-cyclopentyl hexane. This is your cyclopentane hexane. Now if rule number 4, if side chain contains multiple bonds. Now if the side chain contains multiple bonds or if any functional group, then cycling will be again treated as a substituent. So if the number of carbon is more than this one, then again the chain is your treated as a substituent. Again, the chain consists of double bond. If carbon number less also, then this is again treated as a substituent. So this is very important things this you have to remember. So let us see examples. So this is your, you can see 1, 2, 3. So this the double bond is this. We write here 1, 2, and 3. This is your cyclobutyl. So we can say cyclobutyl. So we can say 3 cyclobutyl. 3 cyclobutyl propene, right? Here we have your ketones. We can say 1, 2, 3, 4. See the butanone. So we can say cyclohexyl butanone, because first carbon having this one ketone group. See that this carboxylic acid. So 1, 2, 3, and 4. So 4 is 4. You can say 4 cyclopentyl, and this is a propanoic acid, right? Here propanoic acid. I hope understood why propanoic acid, because in third carbon, not fourth, this is third carbon. So third carbon, this whole cyclopentyl is attached. In this case, we can start with 1, 2, 3, and 4. So 3 and 4 normally there. This is your cyclohexyl, and this is your we can say this cyclohexyl, and this will be your bute. We can say bute. Bute means 2 in is there, so we can say bute 2 in and all. So bute 2 in all, cyclohexyl butanol. This is your amide group is there. So 1, 2, 3, 4. 3 is there. So 3 we can say 3 cyclopentyl. 3 cyclopentyl, and this is your propane. So 1, 2, 3. So you can say propanamide. So I hope you have understood all these things. 3 cyclopentyl propene, this one, and this one. So I hope you all understood. So now we'll see the next rule. Let us see the rule number 5. If a cyclic ring contains multiple bond or functional group, then a side chain is treated as substituent irrespective of the size of the side chain. So there is no limit of the side chains if functional group is present on the ring. So this is the example. You can see the functional group is present on the rings, and here we have substituent. So its name is so 1, 2, and 3. So its name is 3-methyl, and the next is cyclopentanone. This is called as cyclopentanone, right? So understood. Now here is, let's see this examples B. So here we have chloromethyl is 1, 2, 3. This is the your alcohol is a functional group. So 3 we can say 3 chloromethyl, and next is we can say cyclohexanol, right? It's quite easy. It's very easy to understand. So here then you can see the double bond is present on this ring. So the length of this carbon is also 1, 2, 3, 4, 5. So we write the name. So this is your 1, 2, and 3. So 3 means it is your 3. We can say pentyl. So there are 5 carbons. So 1, 2, 3, 4, and 5. So 3 pentyl, and this is called as cyclobutene, right? Now let us see for this one. So we can start from here 1, 2, and 3, because first the substituent is present in this carbon. So we can say this is your 1 and 3 methyl gas. So we can say 1, 3 dimethyl, 1, 3 dimethyl, and this is called as cyclopentene. Okay, I hope you have understanding. Here functional is present, OH present in this carbon. So we start from here 1, 2, 3. This is your ethyl. So we can say 3 ethyl, and this is your cyclobutanol. So that's cyclobutanol, right? Here we can see that. So here double bond is present over here. So we can start from this side only, because we have to move this side. So 1, 2, and 3. So this is the locust, and name is your 2, 3 dimethyl, right? So we can say 2, 3 dimethyl, and this is called as cyclohexene. So cyclohexene, and next is your more this example I have given here this side. So we can start nitro is, and this is your methyl. So we'll take M first. So 1, 2, and 3. So we can say 1 is your methyl. So we can say 1 methyl. So 1 methyl, then comma 3 nitro, and this is your cyclohexene. So these are the nomenclature for rule number 5. Now if the ring have multiple bonds and side chain consist of functional group. Rule number 6, then ring is substituent. Now ring have multiple bonds. You can say ring also have multiple bonds and side chain also contain functional group. Then ring is substituent. So how see? Let us see for these questions. So in that case, so here we can see the OH is given more parity over the double bond. So this ring is acting as a substituent. So again, if you see the all examples, this is given more parity over the double bond, this is more parity over the double bond, and ketone is more parity over. So they always given the more preference, and this becomes your substituent. So let us write first of this name. So this is your carbon 1, 2, and 3. So we can say 3, and this is a complex substituent. So we can write 3 dash. It is your cyclo hex. So we can say 1, 2, and 3. So we can cyclohex 2 enyl, and then becomes a butane 2 all, right? So which is not 2 all because first carbon this we can say this is a but 1 all, butanol. Or 1 we can make it silent also. We can write here butane butanol. This is the better way. When OH is present in second carbon, then you can write butane 2 all. Since it is present first carbon, so we write butanol. So it's not 2 or 1 all. Now here, so B, we can see the carboxylic group is given more parity over the double bond, so this becomes a substituent. So we can write here 4. So we can see here 4 is here our methyl group here. So we'll make this complex substituent. So 4 is 4 dash because fourth carbon is present over this substituent. So 4 methyl, and next is your cyclo hex, then 3 enyl. Why 3 enyl is very clear because double bond is present as third carbon, and then butane, and then we can say not butane, it's here 1, 2, 3, 4, 5. So it is not butane, it's a pentane. So it is called pentanoic acid, right? So this is the example of this one. B structures are pentanoic acids. Now let us see for these examples. So here we have again we can say 1, 2, 3, 4. 4 is there. So and this is again we can say so that is the 1, 2, and 3. So we can write here 4 dash 3 hydroxy 4 dash 3 hydroxy cyclopentenyl, right? Pentenyl, and then next is butane. We can say not butane, this is a but 3 enoic acid, 3 enoic acid. So why? Because between 3 in third carbon in is there. Now let us check for this one. So we can see here. So it is your so ketone is present over here, right? And OH is and hydroxy group is there, and this amines is there. So in that case, it is your we can write this is your this will be acting as substituent. This is your main functional group, the main hydrocarbon substituent, and this will act as a substituent because ketone is present on the ring. So we can write here. So this will be your how much? I think this will be your cyclohexanone. So we can write here 1, 2, 3, 4, and 5. Okay, fine. So this will be your again 1 and 2. So we can write here 2 dash, and amino group is present at this is your ethyl group. So it is your ethyl is there. This is your ethyl, and amino is present at 5th carbon. So we can write here 5 amino ethyl, 5 amino ethyl, not bracket. Again we can write here 2 hydroxy, and we can say it is your pentyl, right? So 1, 2, 3 is your pentyl, and then cyclohexanone. Now this is a little bit difficult, so you just repeat this video just and see each and every step, then you will understand without any problem, right? Now if both the side chain and alicyclic ring contain same functional group, then it is 2 types. Okay, fine. Side chain and alicyclic both contain same function, it is 2 types. So again, if the C is carbon is present in the cyclic alicyclic ring and that is equal or greater than the side chain, and then it is named as the derivative of the C cyclic. For example, here I gave one example. So in that case, how do you write the names? Names will be your. So this is your again we can see is your 1, 2, right? So this is 1 and 2, and this is 3 and 4. So therefore this is 1 and 2. So we can write here 2 dash 2 oxo butyl, right? And then next is cyclohexanone. Fine, clear? So now I think you understood by this whole examples. Now let us see the second one. If the number of carbon atoms of side chain is greater than that of the alicyclic ring, okay, so here you can see the number of side chains obviously is greater than your alicyclic ring, then it is named the derivative of the side chain. How? So let's write them. So how many are there? So as you can see, one we have to start from functional group is from here only. So right here, okay. So this is your how enol is there. So we can see 1 2 3 4 5 6, okay, 7 and 8, right? And this is again 1 2. So we can write here. So 8 is there. So 8, and then becomes 2. This 2 is formyl. So this, let us look very carefully. 8 formyl cyclohexyl, right? And this becomes your oct 6 enol, right? Ali for aldehyde and in for this one. So this is nomenclature for this compound for this rule. Now let us see the rule number 8. Rule number 8, if more than one alicyclic ring is attached to single chain, right? So if more than one alicyclic ring is attached to single chain, then ring is treated as a substituent. So just it is also different group rules, and irrespective of the number of carbons in the ring or chain. So here we have we can see there are 2 rings are there, and one is you can see very clearly single chain is there. So in that case, this 2 ring is treated as a substituent. So we can write here. So this is your methane definitely. So we can say dicyclobutyl, and this is called as methane. Fine. In this case, we can say the 1 2 3. So 3 is your called as pentane. So we can say this is your 1 3. So 1, this is your 1 and 2 and 3. So 1 3 dicyclopentyl. It is called as propane, right? Now here, in this case, there is no methyl group is there. So this one will be treated as a substituent. So we can say this is your how many carbons are there? So we can see the carbons are 6. So cyclohexyl cyclohexane. It's very easy. Now here we have 3 carbon, 4 carbon. So definitely the 3 carbon is you can see this. Here we have 2 carbon is there. So 2 carbon will be treated as your ethane, and this is your substituent. So this substituent again alphabetically. So this is your butyl, this is your propyl. So we can say cyclobutyl, because alphabetically butyl is coming first, and then cyclopropyl, right? And the next is ethane, correct? E group. So in this case we can see again 5 4 is there. So definitely 4 will come first. So we can write here cyclobutyl, okay, fine, and then cyclopentyl, right? And the next is propane. Okay, here this is hexyl, and this is your, now here there is no chain is there, chain is not there. So definitely lower carbon is given the first priority. It will act as a side chain, right? Because there is no you can say there is no chain is present in this case. So this is the absence of this. You can say absence of chain. So in that case, we can write here cyclobutyl, and the next is your cyclohexane. Got it? So be careful. These both are totally different to each other. Now here we see that. Here also very different. There is no chain is there, so we can write here cyclopentyl. Lower this will be given as a substituent because they have 5 carbons, 6 carbons, so it will be substituent. So cyclopentyl, and then is cyclohexane, right? And here because here 5 carbon and this is 6 carbon, right? Here we have 4 carbon and here we have 3 carbon. So in that case, this will be treated as a substituent. So this is your cyclopropyl, and this is called as it will be a butane. So I hope you have understood all this 6 plus 3 8 examples with this rule. Okay, let us see the next rule. Rule number 9, if cyclic ring is directly attached to the carbon containing functional group, okay, cyclic ring is directly attached to the carbon which contains functional group, then the carbon as the functional group is not included in the parent name of the cyclic ring. So very important thing. So functional group is not included in the parent name of the. So let us see. So for in that case, we'll use the suffix for this functional group. So different suffix are used for this functional group. Suppose we have CHO, so we'll use the carbaldehyde suffix. If it is carboxylic acid, we use the carboxylic acid, and COX can be any halides. So we use the carbamoyl halides. And if it is COOR, so we can say alkyl carboxylate. And if it is CONH2, it is called as carboxamide. And if it is CN, then it is called as carbonitrile. So let us see some examples to understand all these things. Here we have. So it is cyclohexane, and this is your carboxylic acid directly attached to the ring. CN, so we can use cyclopentane for 5 carbon, and CN is called as carbonitrile, right? And here we have again you can see here very clearly. So this is your butane, cyclobutane, as UNH2 is there. So it is your cyclobutane and carboxamide as a suffix. We can see here COO esters, so it is cyclopentane methyl carboxylate. Here ketone and carboxylic acid, this is again more parity over ketone. So we use the 3-keto cyclohexane carboxylic acid. It's very important. Here you can see that this is a propane, so cyclopropane carboxylic acid. Here you can say cyclopropane carbaldehyde. This is carbaldehyde, this is carboxylic acid. And here you can see that this is again more parity over OH alcohol. So we can say 2-hydroxy cyclopentane carbaldehyde, right? CHO, COH, so again 1, 2, 3, 4. So this is given more parity over this one. So it is acting as a substituent. So 4-formyl cyclohexane carboxylic acid. Again CN is given 2 CN, so we can say 1, 2 cyclopentane dicarbonitrile. So I hope with these examples it is very you have understood how to write the nomenclature of alicyclic rings with functional group and without the functional group and any substance. So if you like this video, so please subscribe my channels. Thank you very much.